right? So guys, do you have any idea about packet flow and firewall? What we discussed in the last session? Not in this session, like the last where we left the classes. Any one of you who already joined the classes? Okay, never mind. So let's start first with one topic that you are already aware from your routing and switching concept, right? So the name of the topic is NAT. So guys, do you have any idea about NAT? Any one of you? Like what is the purpose of the NAT?
Yeah, it is used to translate public IP to private and private to public, and sometimes it is used
Uh-huh.
to hide the IP information.
Okay, great. So as we know, okay, good evening guys. So we are discussing about here one topic that is known as NAT, right? So NAT stand for network address translation. Network address translation as per uh, as Wiki is explaining. So network address translation is the technology which is used to translate one IP address into another IP address, right? So you can say this technology is used to translate one IP address into other IP address. So that's why we are using the NAT. But this is not the real thing why we are using it. We will come on that point also. But NAT is used to translate the IP address one to another, okay, or many to one. That we will discuss also. So if you say if we have such type of network, so here we are using a device. So I'm just resuming firewall for now, right? And we have internet access, and here is the LAN user. So whenever LAN user is going to access the network, so as we know, we have two type of network. The first thing, right? Or okay, leave for now. So if I'm going to ask, user is using here 10.1 IP address, okay, and here is one server connected on the cloud. So server is like 8.8.8.8, or you can say your DNS server or any Google server. So whenever user is trying to access the server, so traffic must pass through the firewall, and firewall know every route that is exist on the internet. Okay, so that is part of routing. But the point is here, how an user can access the internet? How a user can access the internet, right? So the point is here, if everyone have IP address, and which IP address, guys? That IP address that is routable on the internet. That IP address which is routable on the internet. Are you getting my idea? And normally, if we talk, we have how many IP address? Total 2 power 32. That is the total range of the IP address, 4 billion something, right? So that means only those number of IP address we have, right? So that means in worldwide only these number of IP address can communicate over the internet, right? So that means if I'm saying my organization is using here how many devices. So suppose I have here one organization, right? And my organization have around 5,000 users at a time. So all users need internet access. So what I need to give? I need to give public IP address to each of them, right? What I need to do? I need to give public IP address to every user, right? So that means how many public IP address we need to use? We need to use 5,000 public IPs. Okay. So that means if everyone is using IPs like this, so in that case your IP pool will exhaust soon, right? So that means your IP address will exhaust, right? So pool will be exhausted soon. So that's why they want to translate the IP address. So we have the one concept that can prevent us to exhaust the IP address. So what we can use? We can use concept of NAT. So concept of NAT is saying if you have 5,000 users, so those 5,000 private IP address, those 5,000 private IP addresses we can translate into few public IP addresses, few public IP addresses, right? So that means few means like I can use 10 public IP or 20 public IP, but I no need to use equal to my private IP addresses. So that is the fundamental of the NAT. Okay, I hope this is clear. What is the NAT concept and how it's working? Let's discuss on that, how NAT is working, and later on we will discuss about type of NAT, right? So for now we are understanding how NAT is working. Okay. So NAT is translating the IP address, guys. Okay. 10.10, 20.10. Okay, and this is your internet. So in this diagram we have firewall and we have public IP. So what I'm going to do, I'm going to configure here NAT on firewall. So in NAT, what I'm going to say, if 10.1 will come, you have to translate that 10.1 into 12.11, right? So we created here one entry into NAT table, okay? So that means whenever 10.1 is sending any data, like source IP address is 10.1. So we have some data and source IP is 10.1 and destination IP address is like we have here 2.2.2.2. Okay. So the destination is 2.2.2. So that is going to be sent to firewall, right? So whenever firewall is receiving the traffic, so firewall is going to check I have one NAT role here. So according to the NAT role, what I need to do, I need to translate this 10.1 IP into 20.11 into guys 20.11, right? So whenever traffic is coming here, so they are going to translate 10.1 into 20.11. So now traffic will look like you have here data, and now source IP address will be your translated IP address and destination is 2.2.2.2, right? Okay. So this traffic will forward to here internet. So now internet device will receive the traffic and they will revert you. They will revert you. So whenever they are sending you, so the data is here. Okay. And now the source IP address is 2.2.2 and destination IP address is 12.1.1.11, right? So this is going to send to ASA. So whenever ASA is receiving, ASA is going to check the table, because there is static entry that is going to be checked. Or you can say, if once traffic is forwarded through the ASA create here one table that is known as, guys, connection table. So through connection table the traffic will forward it back, and during that they will read translate the IP address. So this time you have here, this is the source IP and this is the destination IP. So using the NAT rule, now they will translate your destination IP address, right? So the destination is going to be translate into which IP, guys? 10.1 IP, right? So that means it's going to be translate into this IP address. So the data is coming. Source will be 2.2.2.2 and destination will be translated the real IP address 10.1, right? So that how your NAT concept is working actually on any device. It can be firewall or it can be a iOS device. Okay. So I hope this is clear. Everyone. Okay. So now, if this is clear, we need to discuss about type of NAT. Okay. Types of NAT. So these types of NAT we are going to discuss now on which device, guys? ASA, Cisco Firewall, right? So we have normally three type of NAT that we learn from the iOS device. Okay, there are three types of NAT on iOS device, right? But those will be multiple type of NAT on Firewall that we will discuss how. Okay, the thing is same, but we have now more control on NAT, you can say. So normally we have three type of NAT. That is, one is static NAT, right? The second is dynamic NAT, and third one is PAT, right? So we are going to discuss these type of NAT, but now on Firewall, and these three type of NAT is going to become your 7 to 8, or you can say 9 type of NAT. Okay, and we have now configuration way. If you say like this is type of NAT, so in configuration way we have two type of NAT configuration here. We have two type of configuration way. So according to the configuration, we can configure configuration. Okay, so in configuration we have two type of NAT. The first one is network object, guys. Okay, and second is twice NAT. Okay, so that means if we are going to configure NAT on Firewall, it can be static, it can be dynamic or pad. So we can configure using network object. That is the first type of configuration on Firewall. So using network object I can configure static, dynamic or pad, right? And even using the twice NAT I can configure static NAT, dynamic NAT and PAT. So that means the way of the configurations are different, but still NAT remains same, static, dynamic and PAT. Okay, but what is the difference between network object and twice NAT? What is the difference between, guys, network object and twice network? So let's come to that point. If I think this is clear to everyone, the first one is network object. So network object, this type of NAT configuration translates the destination IP address in data. So that means if we are using network object can translation destination IP address always in data. Like in above example we have discussed, sorry, my bad, source IP address. not the destination. Okay. Okay. So that means whenever any user is sending data through the NAT device, so NAT rule, if we have network object, that always translate the source IP address, not the destination IP address. That means if I'm going to create any rule, so for an example, I'm just writing the rule here, and then I will explain the same rule. So in global mode of the firewall, I'm going to configure like object network, and here is my NAT rule one, right? So this is the name, NAT one is the name. I need to give here IP address, so this is my real IP address like 10.1. Okay. And after that I need to configure here NAT. Okay, I need to define my inside interface, and then I need to define my outside interface. Okay, I need to define type of NAT is static, and in which IP address I want to translate it, in which IP address I want to translate it. So that IP address I need to define here, that is the translated IP address. Okay, for now just understand what I did, and through this example I will explain you how network object is going to translate the source IP address always. Okay, so let me write down the firewall. Okay, so here we have internet client have 10.1 IP, gateway is 10.10, 20.10 is the IP here, and this is the internet. So here I have my the name of the interface is inside. Okay, and here name of the interface is outside, and security level is 100, and here is 0. So that means whenever traffic is coming, NAT is configured. Okay, so we have here NAT table also. So NAT table have static entry because NAT is static, so accordingly 10.1 is going to translate into 12.11 IP. So that means if any traffic is coming from here, okay, and in that we have source is 10.1, destination is 2.2.2, any public IP address. Okay, so the traffic will come on firewall. So whenever traffic is received on firewall, firewall is going to check NAT table. So NAT table, it will check the source IP address is 10.1, which is going to translate into this IP address. So this is going to translate the source IP address, which is into 20.11, right? And the destination IP address remains same. Destination IP addresses remain same. So that means this NAT object network rule is just translating one IP address at a time, not the multiple IP address. And that is only translating the source IP address, guys. Which IP address, guys? Source IP address, right? So this is the source IP address which translate into 20.11. So network object can translate only source IP address in rule, not the destination IP address, not the destination IP address. Yeah, it can translate the destination also, but you need to define maybe multiple rule. You need to define maybe multiple rule. But if we have only one rule right now, so this rule can only translate, can only translate source IP address. I hope this is clear to everyone, guys. Is it clear? Okay. Vidya, Vicky, Kenel, Daniel. Okay, cool. So this is about object network. So that's why we explain about a network object translate the source IP address. Okay. So the next one is twice net, guys. So what is the concept of twice net? Twice net actually can translate source and destination IP at a time. Okay. Twice net. you can see it can translate the source and destination IP address at not at same time in a single rule, right? So that means single rule of twice NAT can translate source and destination IP. It can translate, guys, source and destination IP address. So that means if we define here configuration for that, okay. So let me show you how. So what I'm trying to do in same diagram, okay. So this is the rule. Okay, this is the network diagram. So in this we have created now suppose twice NAT role, and in this NAT role what we'll say in NAT role, if 10.1 is coming, you must translate into 20.1.1.11, right? And in the same rule, if destination is coming like, okay, so this time suppose I'm going to hit here another IP address, like I'm going to hit here 10.11, okay. So if destination IP is 10.11, that should translate into 2 to 2. Just for an example, right now, like this will be very complex to explain why I'm translating 10.11 into 2 to 2. But just try to understand if 10.1 is going to hit on one IP address, 10.1 is going to hit on one IP address which is belong to the same network, right? So now maybe for security reason we don't want to tell about 2.2.2, right? Okay, this is not maybe outside network or it can be some DMZ network for you. Okay, so at that time your traffic will come using the 10.10.1 IP and it will use destination IP 10.1.1.11, this IP address. Okay, so the traffic is coming on firewall this time. So whenever traffic is coming on the firewall, firewall is going to translate both the address. So it's going to translate 10.12 into 20.11. Okay, so data still remain here. Source is 10.1 which translate into 20.11. Okay, and destination is your 10.11 and 10.11 is going to translate into 2 to 2. So that how device can translate source and destination IP using a single NAT role, right? Using a single NAT role. So that is the concept of twice NAT. That is the concept of, guys, twice NAT. Is it clear to everyone, guys? Okay, I hope this is clear. So now we are going to discuss if this is clear to everyone, type of the NAT, right? So we have type of NAT, static, dynamic, and PAT. So these three type of NAT we can configure using network object or we can configure using twice NAT. But the point is network object can only translate the source IP address and it can translate the source and destination both IP address. So that means this rule is giving you more you can say options at a time. Okay, but not the network object, but both have their own use cases that we will discuss. So I'm starting now with types of NAT. So first of all we are going to configure every type of NAT using the network object. So in network object we are starting with static NAT first, with static NAT, right? So whenever we are going to configure the NAT, So always we have two type of IP address. Always we have two type of IP address. Okay. First of all, can you tell me about static net? What is static net? Any one of you?
One-to-one mapping.
Okay, right. So static NAT is used for one-to-one mapping, right? This is used for one-to-one mapping. We can use one-to-many also, but you can say this is used to create static entry, right? Okay. There can be one-to-many also or many-to-one also. Okay. One-to-one mapping means not only I'm not only talking about IP. Maybe it can be belong to port number as well, right? So we have static pat as well. This is static net right now, but there can be static pat also. Okay. So if I just talk about static net, so that means there is one-to-one mapping. I'm talking about IP to IP mapping. Okay. And this is also known as NAT for servers. Why? Because we create static entries for server NAT. That means if any user trying to access your server from a public network, so you create a static entry. You create a static entry. Why? Because static NAT is always bidirectional. Static NAT is this is bidirectional NAT. Okay, which means traffic can be initiate from inside or outside network, right? So that means traffic can be initiated from anywhere, inside network and outside network. Okay, so that is the meaning of the bidirectional NAT, if you remember from the routing and switching. Okay, so I will show you. I always initiate the traffic from outside, so that time I can show you. Okay, but rule always created for inside net. Okay, like what? If you, okay, we have this network object, right? So this is a static net. If you say we have this and this is your static net. Okay, so in this static net, guys, see, I created here one entry, so in which we have one IP address, that is 10.1 IP, and as we know 10.1 is my real IP address. 10.1 is real IP address, right? Okay, so this is real IP address, and the second one is 20.1.11. So 20.1.11 is translated IP, that is also known as after NAT IP, right? After NAT IP. So that means your host 10.1 is going to be, you can say, that will be visible on a public network using this IP address, not with its own IP address. Why? Because the private IP addresses are not routable on public internet, right? So that's why we have here public IP address for that. Okay, so that is real IP and that is translated IP. And now we have here two interfaces. One is known as real interface and one is known as mapped interface. What is the meaning of real interface, guys? What is the meaning of real IP, real interface? Okay, real interface means where source IP translate, right? So that means where source IP address is going to be translate, that is your real IP, real interface. So real interface is your inside. If you check in this diagram, right? So real interface is here your inside, in where 10.1 is source IP address, which translate into 20.11, right? Because this is our network object. If you talk about static one, if you check here, so traffic is coming from 10.1 to 2.2, right? So 10.1 have entry in the table that will translate with 20.11, right? So that means source IP address is going to be translated on this inside interface. So that means inside interface is real interface for me for this particular role, right? That is my real interface, right? And whenever traffic is coming back from internet to outside interface, so that time source is like my public IP address 222 and destination is 20.1.1.11, right? So that IP address is 20.1.1.11, which translate into 10.1.1.1, or you can say untranslate. So whenever traffic is coming from internet to outside interface and on this interface, when destination is going to be translate, okay, so when destination address is going to be translate, that is known as mapped interface. That is known as mapped interface. So mapped is your outside interface, guys. Are you getting my point? So I discussed about two things here. The one is real interface, the second is mapped interface. Okay, real interface means where source IP address translates, right? And mapped interface where destination IP address translate, right? Is it clear to everyone? So that means if my traffic is going from inside to outside, that time my source IP is getting changed. So real interface, which is your translating the source IP, and when maybe traffic is also initiated from the outside world, right? So that time your destination IP address is going to be translated. So that is your mapped interface. That is your mapped interface. So whenever you are going to define the rule, so always rule is created for the real IP address. So this is my real IP address. Okay. So what I'm saying in the rule, if host 10.1 is come on an inside interface and move to outside interface, so there is static entry for that. You have to translate. Okay. So in which I define the real IP. So this is my real IP in my rule. Okay. And this real IP is going to be translated into which IP, guys? The translated IP address. Okay. Okay. And after that, which interface is going to be your real interface? So inside is my real interface and outside is my mapped interface. Is that clear to everyone, guys? Okay. Daniel, Kenel, Odilo, Vicky Chopra, Vidya. Okay. So now if this is clear to everyone, so I will show you the configuration of NAT, and with that NAT concept, I will explain you the packet flow of ASA also, how the packet flow is going to be changed. But before that, I will configure the, okay, so I guess this is our network, which we used in the last class. So here we have network 10, 20, 30, right? So I will only use 10 and 20 and use it, R1. 1. So firewall don't have any configuration. Okay. And I guess routers have configuration already. Let me check on router first. There must be configuration. Yeah, it have IP 10.1. Okay, loopbacks as well. It must have route. It have loopback of 222 and 3 and IP and route as well. So it's time to configure the firewall. My bad. There is no password. Okay. Configuration terminal. Host name is ASA. First of all, we are giving IP address on interface 0 by 0. No shutdown. Okay. Name if is required, that is inside. So inside have always security level 100. And IP address is here 10.10 slash 24. Interface kick 0 by 1. And name if is here outside. Okay. And every other name have security level 0, but you can give if you want. Okay, with this command. But we are not going to configure, that is enough. So here is 20.10. Okay, so we configured here. Okay, now uh, we can check show interface IP brief. Okay, show routes. So if we can try to ping 10.1 reachable, 20.2 is R2, it's also reachable. So the by default everything is here. Just I'm going to configure the NAT now. Okay. So for NAT I'm using first of all network object concept which we discussed for static NAT configuration. So the command is object network, and you can give the name is rule 1 for me. First of all you need to give the real IP address, and we can give here real IP like this. I'm giving here single IP address of the host for now, just to show you one-to-one translate. Okay, in static NAT. After that, you need to define NAT. Okay, and you need to give the real interface. If you check, we have here interface names like any can be for every interface, but for not for now. I will show you later where we can use any. But here, if you check, you have here open parentheses like with a small bracket. Okay, we can give here internal name if and the external name if of the interface according to the traffic flow. Okay, it's not only internal is not only about inside or outside. Okay, it can be any interface, but you need to understand the packet flow, and accordingly you can decide which is the uh, real interface and the mapped interface. Okay, so we need to give here inside. Okay, then outside interface, static, and the translated IP address. Okay, just a minute, guys. Give me a minute. Hello. हाँ Okay. Okay, guys. So we were configuring the static NAT configuration on firewall, right? So we configured the static NAT on firewall. So if you check the configuration is visible here, right? So we configured NAT in real interface and the mapped interface and the static entries here, right? So this is the static NAT. If you check show NAT, so that is visible here. Okay, so what is the section 2? We will discuss that also, but not now. And now see, this is our entry 1 which have real interface and the map interface. Okay, and this is translating the source IP address statically in rule 1 into 20.1.1.11, right? And if you want to check the entry, show network, wait a minute, object network, not this command, show net. The command is, I guess, network object. Wait a minute. I'm looking the command. There is a command which show you about show run. mm, Object network. Okay, so here you can check which host you are going to be translate. Okay, and show run net. So here you will get the net. So both will not visible into that into same configuration. So this is for host and this is for the net rule which we configured inside it, right? And now right now we don't have any entry. But in this rule, I want to show you some things. If you configure show net, in this output, there are two things. One is the translate hits and one is untranslate hits. What is the meaning of translate hits and untranslate hits? Anyone know? Guys, any idea? Okay, let me explain you. So that means whenever traffic is so the first thing you must know static net is bidirectional, right? In this bidirectional net, traffic can be initiated from can be initiated from inside or outside, right? So that means traffic can be generated from anywhere else. Okay. Now rule is always created from inside network. So that means whenever you are translating, you are sending data from 10.1, that must be translated into 20.11, right? Because we want to translate always source IP address. So that means that rule is always created according to the uh, inside network. Okay, or you can say the real network. Okay, to translate into translated network. So now according to the flow, translate hits, those are increase, those are increase when traffic is initiated from real to mapped interface. That means when traffic is sent from real to mapped interface, right? From inside to outside. So that time translate hits increase. Okay. And untranslate hits is opposite of it. Untranslate hits when traffic is initiated from mapped to real interface. That means when traffic is coming from outside to inside. Okay. because rule is same and rule is for both traffic, for inside and for outside. So in this diagram, so here we have this diagram. So now, so the traffic is coming from 10.1, right? So whenever traffic is coming like this, so this is my real interface according to configuration, and this is my mapped interface. Why? Because 10.1 is the source IP address which translate into 20.11 IP address, right? But maybe there can be same traffic flow but from outside network. So maybe if any user is existing here, so user can send traffic to firewall, right? So this time traffic is initiated from outside world. So when traffic will hit on this interface, so it will check the same rule. This is the rule, right? So that time destination is going to be translated into this IP address, because source can be 2.2.2, right? So source is 2.2, and this user is going to hit a IP address 20.1.1.11. Why? Because everyone hits your public IP address, not the private IP address directly. So the device is going to translate the IP address, okay? And NAT table have static entry. So that means when user traffic 222 is coming to 20.1.1.11, so that 11 IP address translate into 10.1. So that means when firewall sending data to the real device, so it will send like 2.2.2.2 is sending data to 10.1.1.1, right? So this time your mapped interface is translating the data, right? So that is known as untranslates hits. Untranslate hits means traffic is initiated from outside. Traffic is initiated from outside, or you can say the map interface, and sent to your real network or real interface, right? Okay. But normally whenever traffic is initiated from LAN to WAN, so that is from real to mapped, so that is translate hits, that is increase under that translate hits. Okay, so make sure about that, and you can check why the translate hits are increasing, why untranslate is increased, right? So in that case, if I'm trying to initiate the traffic from R1, I will do telnet. I need to telnet to 20.2. Why? Because I have not given the route on firewall. Is it allowed? Let me check. I'm not sure. Yeah, transport input all. Okay. What's wrong with you? Okay. Maybe first time it was taking time. Admin and Cisco. So we have now connection, right? And now if you check the same rule, so we have here two hits. Why? The traffic is initiated from LAN to WAN. So that is from real interface to mapped interface. Okay. So in that case, translate hits increase. In that case, translate hits increase, right? And now if you check show cone. So in even in the connection table, you can see even in the connection table. Just a minute. This is not showing about the translation. We have to check con long, right? So here is just your TCP connection. We are sending data to 20.2 on port 23, and this is the inside IP on this port number, right? And these are the flags. But you can check using the show con long command. And here, see, the traffic is initiated for outside network for 20.2 IP. So 20.2 IP is the same IP that is not translated in any IP. Okay, and traffic initiate from inside network. The real IP is 10.1. That is translated into 12.11. Right. So that is your entry into which table? Escalate table. That is NAT table, guys. Okay. So NAT table is escalate table. You have entry. See. So here you can check NAT is configured from inside to outside network. Okay, 10.1 to 20.11. The flag is showing as mean static entry, and this is the timer, idle timer, and timeout is 00. Okay, so we have created here static NAT, but normally static NAT is created for server, right? For servers. So for an example, we have same network here, but right now I'm just going to create one more NAT rule. Okay, so what I want, like R3 is here and R3 have two servers. R3 have two servers, and here I have some users on internet, right? So these are the public users. Okay, so these users are trying to access my this server 1 and server 2. Maybe they are trying to access on port number 80 and port number 23. Okay, both the services, but I have here NAT device between them. I have NAT device, or you can say right now I have only one server. Maybe I'm using the real IP address 30.1.1.3 for this time. Okay, so what I want, if anyone is coming from outside world to my server, so firewall will translate. So what I want to translate here, guys, object network. Okay, so this is for DMZ, my DMZ network, and I want to translate 30.1.1.3, and I'm giving here NAT rule. Real interface is DMZ, mapped interface is outside for me, and I want to give a static entry like 20.1.1.12 this time, because 11 is I'm using for the LAN. Okay, so I'm giving here. So if anyone is coming for 20.12 IP, so that automatically translate into 30.3 IP, 30.3 IP. So that means this time I want to initiate traffic from outside to DMZ. So that is going to be untranslate hits for me. That is going to become untranslate hits for me. Are you getting my points, guys? Or is there any confusion? Everyone? Okay. You can unmute yourself and you can ask if you have doubt. Okay. I hope this is clear. I will configure the rule, then I will explain you, okay, about that. So I'm not deleting the last one, but this time you need to again remind your packet flow, guys. What do you have to remind? The traffic flow on ASA. I will show you why. Okay. So let's create the rule, guys. So this will be the rule, okay? So again, remember which is your real interface and which is your mapped interface. So this is your real interface and this is your mapped interface. But how? Okay. So what we want, just let understand the traffic flow first. Okay. So this means we have here some user. Okay. So just an example, user have IP 2.2. Okay, and that is trying to hit, or that is trying to access my server, but I will not give my real IP address in the public world, right? From for security reasons and other reasons, right? So now we are giving a public IP. So that means source is 222. That is going to hit on a public IP address 12, right? So what I want, this 12 IP address must translate into my private IP, into my private IP. So 12.1.1.20.1.12 is going to be translated into 30.1.1.3. So that means 12.1.1. Sorry, my bad. 20.1.1.12 is the IP. Okay, so user will hit on this IP that will translate into 30.3 IP. So in that case, which IP is translating on this interface? Source or destination? Guys, which IP address is translating here? So the traffic is coming, data is coming. Source IP address is 2.2. Okay, destination is 20.12. So what do we want? 20.12 translated into 30.3. So according to that traffic flow, which IP address is translating here? Source or destination? The destination IP address, right? Destination is translating into 30.3, right? So that means on this interface, destination IP address is translating. So that is going to become my mapped interface, right? So automatically other interface is real for me. And I need to create NAT role for real interface. So what I need to do, object network, host is always the real interface IP address. So real interface is my DMZ. So server IP is 30.3. So this is my IP address which belongs to real interface, and I need to give here NAT role DMZ outside static 20.12, right? So that is going to be my NAT configuration. Okay, I hope this is clear now to everyone. So let's start. So we are using object network role 2. Okay, host 30.3. Okay, before that I forget to configure IP address on that interface, so maybe it will give me error, but let me try. There is no DMZ interface actually. I will show you if interface is not there, you can't configure. Even you can see outside static 20.12. So it will give you error on DMZ. See, there is no DMZ. So what do we need to do? Interface gig 0/2, no shutdown, name if DMZ, security level 50. Okay, IP address 30.10/24. Okay, now we can configure the role. Okay, so IP address is already defined for the host, so I can configure this one directly. Okay, so that means now NAT configuration is done. If you check show run NAT, so we have rule 2. Okay, you can see the DMZ is the real interface, outside is the mapped interface, and show run object network, and here is the IP address of the host. Okay, and even if you check, escalate table have entry for both, for 10 and for DMZ as well, right? Is that clear to everyone? So this time I'm initiating the traffic from R2, okay, to R3. But let me check on R3. Do we have telnet configuration and everything? Okay, we have everything. And now let me start from R2. Telnet, not this. I need to give to 12.20.12 IP. So wait a minute. Maybe for the first time it will give me this error. Let me try again. Still, we have something. And what is that? Okay, let me do one thing. I can use one command if you remember, guys. I can use packet tracer command, okay, from input from outside interface, and that is TCP traffic initiating from 12.2 on port number 104, a random port number, right? And the destination is 20.12 on port number 23. So see, again you need to remind your packet flow, right? So the traffic is coming on firewall. Okay, so firewall always going to check first which table, guys? Connection table, but there is no entry for the first time. Then
Routing table.
yeah, routing table, correct. Okay, so routing table give you idea about which interface? Exit interface. Which is the exit interface? After that, firewall
At
get to know DMZ is the my exit interface. But now there is one thing, that is SLP, that is SLP, service level policy, right? So this time the traffic is coming from interface which have security level 0 to interface which have security level 50. So and inside have 100. So outside interface have the lowest security level number 0. So that means there is no SLP. There is no SLP. So if there is no SLP, traffic will come to firewall on the global policy. On the global policy, guys. And what is the global policy? Deny IP any. So traffic will come on global policy and will deny. If you remember, right? That was the traffic flow. And if you want to see, okay, so see, the first firewall check MAC access list that is not configured. Second, device is not checking routing table here. I will tell you why. But for now, it's going to be check unnat. That means untranslate net. Translate means from real to mapped, and untranslate mapped to real, right? So the traffic is coming from unnat, and outside interface have the real. So this is the real, and outside is your mapped, right? So that's why it's showing unnat. Okay. And if you come, okay, so we have here static net, traffic is showing allowed, okay, and the rule is matching here NAT rule number 2, in which NAT is from DMZ to outside, okay, there is no problem. And using NAT, you can see NAT divert to egress interface DMZ. So routing table is not checked here, guys. Routing table is not checked here. Why? Because if you have NAT configuration, so they will check the NAT, that is destination NAT, that is destination NAT. Okay, I forgot to explain you about, one is destination NAT and one is source NAT. Guys, you know the difference between destination NAT and source NAT? Any idea? Just a minute, guys. Okay. So now the destination NAT is giving you idea about exit interface. Why? See, in the destination NAT, the traffic is coming on your mapped interface outside, right? And other interface is here DMZ. So automatically destination NAT is giving you idea. Traffic is coming on outside and you have to send to DMZ interface. So that how you get to know about exit interface. So routing table is not required, or you can say the task of routing table is done by your destination NAT, right? And what is destination NAT? The point is very simple. The traffic is coming from from client to outside interface. So on outside interface, device is translating destination IP. So that is destination net for me. Okay. The device is translating destination IP because the traffic is coming for this IP address 20.12 and we are translating 20.12 into 30.3. So this is destination IP address in my packet. Why? The source IP address is like 20.1.1.2, the IP address of router, right? So in this 20.12, which is destination IP, is translating into 30.3. So on this interface, device is translating destination IP address. So I can say this is destination net. I can say this is destination net, right? Are you getting my point? And in opposite, if traffic will go from this server to router, so here we have real interface and this is the mapped. So real is going to be change your source IP address. Which IP address, guys? Source IP. So source is 30.1.1.3 translated into 20.1.1.12. So if your source IP address is translating into the packet, so that is source net for me. That is source net for me. So according to traffic flow, we can say source net and destination net, right? So the traffic is coming on this interface. So the first of device is going to be check the connection table, which is not there. Second is routing table, but routing table is not required to be checked because of the destination NAT is giving you idea traffic must forward to DMZ interface, right? Which interface? DMZ interface. And the third thing, SLP is required to be checked, but there is no SLP because of security level 0. So that's why traffic moved to global policy and which will deny the traffic, right? Deny IP any. Okay. So why deny IP any? Because from security level 0 to 50, right? And if you check, they have same thing. See, the fourth is access list drop the traffic. And what is the reason? Implicit deny. What is the reason? Implicit deny. Why? Because the global ACL, or so you can say the global policy, drop the traffic. So whenever traffic is hitting from lower security level to higher security level, you have to do one more thing with it. You have to do one more thing with it. You need to apply ACL. And what ACL you have to apply? You need to permit TCP traffic from source this with a random port number. Random port number is no need to be defined, right? So we have to permit TCP traffic which is coming from host 20.1.1.2, the IP address of R2 interface. To which host, guys? To which host? Tell me. Real IP address always. Real IP address, okay? And what is the port number? Port number is 23. So this ACL we need to apply access group, whatever name can be, like name can be my any name I can give it, like the DMZ, okay? In interface outside. So that how you have to apply it. So you need to permit your traffic. So whenever you're going to configure ACL on firewall, make sure ACL have always entry for real IP, always entry for real IP, not for translated, because we have two IP here. One is this, sorry, 20.12, right? That is mapped IP. That is mapped IP. and second is 30.1.1.3, which is real IP. So ACL always need to configure for real IP address, not for the mapped IP. Okay. So now let me show you. We need to configure the ACL access list DMZ. Okay. Permit TCP host 20.2 host. Okay, let me show you if I'm going to configure for by mistake mapped IP, will it work or not? Just to show you, okay? Access group DMZ1 in interface outside. So we applied it, and now let me try packet tracer command. First of all, I will show you from R2. Okay, so we did telnet, but still it will not work as we know. I can show you in packet tracer. Packet tracer input outside interface TCP traffic from 20.2 on a random port number. Port number can be anything. Let me use the 5 words, okay, or 5 digit. And to destination is 20.12, port number 23. Traffic is matching with the rule, no problem. ACL is dropping your traffic, and you can see that is untranslate from 20.12 to 30.3, and the traffic is still dropped. Why? Because in ACL we configured the wrong IP address. So what I need to do, I will add another entry in the same. Okay, so access list. So I created one more entry. So this is the old one, and I created new entry. Okay, with line number 2, like a new sequence number. And this time if we try, see, first of all NAT is matched, right? And NAT is giving you idea to untranslate and the exit interface. Okay, uh, un- with DMZ exit interface is DMZ and untranslate. And then you have access list. So access list is going to be check, right? And which access list? 20.2 with destination 30.3. So here is entry for real IP. Okay, and after that you can see the traffic is allowed. The traffic is allowed. Okay, so if now I do show exclate, we have entry, show con long. So we don't have entry. Now I can generate traffic from R2 to R3. See, so now we have here access of R3, access of R3. So I hope this is clear to everyone. If this thing is clear, I can come to traffic flow of ASA now. Guys, everyone is getting my point. Okay. So if this is clear, let me show you the actual traffic flow, or let's discuss the traffic flow of the firewall. Okay. Vidya, Vicky Chopra, Kenel, Daniel, good to go. Okay, great. Hmm. So now, actual traffic flow of ASA. Okay. So the first of all, like data is coming on the device. So whenever data is coming on the device, so traffic will come to ingress interface, right? So when traffic is coming on ingress interface, so there must be increment in bits or bytes. So there is byte counter which increment the count, right? So byte counter that will increase, right? Okay. And after that, once traffic is coming on the interface and byte count increase, so first of all, firewall always going to check one thing, that is connection table. That is connection table, guys. Okay. So if there is no entry in connection table, then traffic is going to be moved to the next point. And what is that? Destination net. Firewall always check the destination net in that case. Firewall always going to check, guys, destination net. Okay. Are you getting my point? Okay. And now after destination net, device get to know about exit interface. So okay, so in that case, routing table is not required to be checked. Okay, so we can say device will check here exit interface with destination net. Okay, so let me make it short. So now we have here exit interface. Okay, now device have exit interface with destination net. So now device is going to the next point. And what is that, guys?
SLP.
That is access list, because once device check there is no entry in connection table. Okay, so after that device check the destination net is configured or not. So similar in our case where we configured the destination net, right? So we configured destination net on the device. If you check show run net, sorry, this is router, show run net. So if you check, we configure net. Okay, and static net with translated IP 20.12 show run object network. So we configured for 3333, right? So that means 30.1.1.3 IP is going to be translated into 20.1.1.12. So this is destination net. Why? Because the traffic is coming on mapped interface. So mapped interface is receiving destination IP 20.12, which translate into 30.3. So here we are translating destination. So they first check the destination rule instead of source rule. Okay. Now after destination net, device must check the access list, and that is after the net. That's why this is for which IP address, guys? Real IP address. So if you remember, we configured the ACL for real IP 30.1.1.3, not for 20.1.1.12, right? Okay. And after that, there is inspection of the traffic. There is inspection of traffic. Like if you want to inspect any layer 7 traffic, any layer 7 traffic, right? So we can inspect that using the inspection engine here, right? So inspection is always the destination net and after ACL. So that is after the destination net and after ACL. Okay. So once inspection is done, then device is going to be check source net. Okay. Source net is always after the inspection. After the inspection. Okay. Now the next thing is here virtual traffic. What is the meaning of virtual traffic? So firewall forward virtually traffic to interface. Virtually traffic forward. That means uh, firewall get to know about where is your exit interface. So exit interface in our case is DMZ, right? So that means now firewall check ACL and do inspection, and if there is source net, it will do the source net, and then they virtually forward the traffic to interface. Virtually forward the traffic to interface. So that means what is the meaning of virtually here? This virtually means they are trying to send data to the software queue of the interface, not the hardware queue. Software queues are like line where you can put the traffic before process it on an interface, right? So that means if we have here a firewall like this, okay, so the we have DMZ interface here. So firewall send traffic to this interface, but not on the hardware, not on the IO module of the device. It will send on the software level of the interface, right? Because first software will interact, then you push the traffic on hardware of the interface. So first of all, there can be multiple queues like this, the lines. So they put in the line, right? They put the traffic into the line. So there can be multiple queues like this on the interface. So the first traffic is coming maybe in this queue, maybe in this queue, before moving to the physical interface itself, right? So that is virtually traffic forwarding on the interface. Are you getting my point, everyone? Okay. So once traffic is forwarded virtually on the interface, then firewall must check. Then firewall must check what is the next thing. Okay, that is software queue. So after that, firewall is sending traffic to physical interface. But before physical interface, on when traffic is existing inside the queue, at the same time, firewall is going for interface route lookup. Interface route lookup. What is the meaning of interface route lookup here, guys? That means is that route existing in the routing table or not? Firewall must check route is existing in routing table or not. But you can ask here, if firewall know the exit interface, then why firewall need to check the route? Maybe by mistake there is some misconfiguration in the NAT. So using NAT, you can get to know about exit interface, but maybe the entry is wrong. There is no any specific route. So without route, how firewall can send data? Are you getting my point? Like here is the firewall. Okay. And this is your exit interface, right? According to the NAT role. So NAT role is saying 30.1.1.3 is translating into 20.1.1.12, right? That is clear. Okay. But maybe in future you have here like router and you are going to be put some servers, and servers IP is like 3.3.3. So this time you have created here route. You have created here route, or like this time you want to translate 3333 into 20.1.1.12 IP, right? Into 12 IP. So this time you forget to give here route on firewall towards R3. So that means you forget to give here static route, or maybe there is no dynamic route in table, right? So that means NAT is configured and NAT is still saying NAT DMZ outside static 20.12 IP and host is 3.3.33. So you did the configuration. So this NAT is giving you idea about exit interface DMZ, which is this interface, right? But on firewall, you forget to give route for 3333. So there is no specific route, right? So that's why firewall need to check about interface route lookup before moving the traffic on physical interface. Make sure on the same interface you have route for the real IP. You have route for the real IP, right? That is the meaning. Okay. After that, the traffic will forward to the egress interface. Egress interface means the hardware queue. Egress interface means on the hardware queue, right? So traffic will forward on hardware queue. Hardware queue. After that, firewall check layer to next hop lookup. Layer to next hop lookup. What is layer to next hop lookup, guys? Layer to next hop lookup. What is layer to next hop lookup? That means if you are forwarding data to this user which is behind the R3, so the next stop is 10.1 30.1.1.3. So this is next stop to reach 333. So firewall know if I want to reach on 333, this is my next stop. So is this next stop also reachable to me? And do I'm able to resolve the layer to address, or I'm able to resolve the R for that or not? So that is check under the layer to next hop lookup. Okay, so that means make firewall make sure for next hop IP address I'm able to resolve the layer to address, layer to MAC address. So that is whenever traffic is on your physical interface before forwarding it, right? Okay. And after that, if everything is good, now traffic will exit the interface successfully, right? So this is traffic flow, guys. This is traffic flow. So in this traffic flow, do you have any doubt? Any one of you? Guys?
No doubt.
Okay. So let me show you. So I will show you inspection also. So right now I'm going to configure inspection on firewall. So the inspection is very easy. I can do the same thing. And ACL is already there. Now let me configure inspection. So if you remember how to configure inspection, just we have to match the traffic first. Okay. And I'm going to match the traffic in ACL. So that is my telnet traffic permit TCP traffic from anyone with port number 23. I need to configure class map. Okay. Match access list telnet policy map is map. Okay. And class is cmap, and like we want to set the connection, right? Set connection con max 2. Okay. And exit we need to apply into service policy in, wait a minute, okay, that is map in interface not inside, that is my outside interface this time. Okay, so we want to inspect traffic coming from outside to DMZ. So for that we have applied here one class map. So here what I want to see, so like we have now destination net, we have ACL, and the next thing is inspection. So I want to generate the traffic manually. uh, Input from outside interface, the TCP traffic, right? And the host is 20.2 with a random port number to 20.12 port number 23, right? So if you check, so first of all the device is checking an NAT, that is destination NAT for me, right? And now you can see the device is getting here idea about egress interface. Okay, so device get to know about egress interface, and after egress interface device check the ACL, and ACL is always for the real IP address, right? Okay, and now after that you can see we have here now inspection. So third step is inspection, which is checking the class map, C map, policy P map, connections, okay, which is applied on your outside interface. So that means what flow we have discussed, that is exact same. So there is no entry in connection table, so that's why there is destination net, which giving you idea about exit interface, okay. And then there is ACL for real IP address, okay, which is already configured if you remember. Then we did inspection for layer 7 traffic. Okay, so now we are not going to perform source net or anything right now, because net is still we need to discuss. Traffic will forward it here, and we need to check now this step, interface route lookup. So for interface route lookup, what I can do, I need to change something. What I need to do, I can configure loopbacks on R3, and I can give route on ASA for that, right? But suppose we are on R3, show IP interface brief. Okay, we have loopbacks. So I'm going to change the rule now. So what I'm going to change, show run NAT. So I'm going into the same rule. No host. I'm going to remove the 30.3. Okay. Unable to delete the rule. Object is being used. Right. Why? Because there is entry, I guess. And okay. Show con. Show exclate. Yeah, there is entry actually. So what do we need to do? No object network role 2. I removed it. Object network role 2. This time my host is 333, right? NAT DMZ is the real interface, right? Outside is the mapped interface 20.12. Okay, and even I need to change in the ACL, show on access list, right? So let me remove, we have here DMZ, okay, this is the IP address. And okay, let me give another entry inside the same access list. DMZ1 permit TCP host 20.2 to host. I need to give the real IP this, okay, port number 23. So ACL is already applied on the outside interface if you remember. So just I created, and I have not given the route. If you check, there is no route for 30 network, so that is route lookup. So firewall will check for route lookup. If you check, I do the packet tracer command again. Packet tracer input outside interface, okay, and source IP is 2 on a random port number. Destination is 12 on port 23. Wait, traffic is TCP, okay. So now see, we give this command, okay. So first destination NAT is checked, which is giving you exit interface. Then ACL is checked, right? So this is now for 30.3. ACL is checked and traffic have forwarded successfully after the ACL, right? And even your connection table is checked. Connection table have entry too actually. Maybe because of that they dropped it. Uh, yeah. What should I do? Wait a minute. I need to increase the connections. Okay. Set conmax 200. Okay. So now let me generate again the traffic. Okay. So this time the traffic is forward through ACL and even through the connection, right? The inspection, so there is no problem. So in your packet tracer command, your traffic is forwarded. You can see the traffic is allowed, and there is one more thing. If you check, yeah, see the RFP. That means reverse route lookup. But in packet tracer, traffic is allowed. But in real, if you send the traffic, telnet uh, 20.1.12, so there is no telnet. Why? Because firewall don't have route. So if you check in the logs, if you enable the logs, guys, logging enable, logging console 7, video net, okay. Let me generate the traffic again. See, you will get this error, guys, if you don't have route to reach the destination, but maybe you have created the entry. So in NAT table I make the translation for 333, but I don't have any route for 333. So that is the reason where I am getting this error, where I am getting this error, okay. So this is about interface lookup, okay. So you have to give the correct route. So maybe I can give the correct route, but maybe I give the wrong next hop, and for wrong next hop firewall will not resolve the MAC address. Why? Because wrong next hop never have any MAC address, right? So for that layer to next hop there will be no log message, there will be no log message. So we have to enable ARP for that, okay. I will show you, wait a minute. So I am giving here route on my DMZ interface for 333, okay, and next stop is, suppose I have given the wrong, okay. So right now you have route and routing table, okay. So there will be not that problem, and even you will not get the same log message because route is here, okay. Okay, so what I need to do, debug ARP, and now on R2 let me try again. See, ARP send, and you will get this error, guys. Okay, pending ARP. Okay, so that will be the error at layer 2. So that is the idea about packet flow here, guys. So if you have any challenge, let me know. So let me correct it. Okay, 3. So this time you will get the, see. Okay, so that is all about the traffic flow of the firewall using the NAT, ACL, inspection. Okay, so we discussed everything. So if you have any doubt, please let me know in this. Anyone, guys? All good? Everyone?
Not all, but let me go through the video, then I'll get back
Okay,
to you.
yeah, go through the video. And if
Thanks.
you have any doubt, I will explain again in tomorrow class. Okay, so class will be on
Yeah,
the same
sure.
time, 8 to 10:30. Sorry, 8 to 10 p.m. IST. Okay. So tomorrow we will discuss about static net. Like we discussed here, just one-to-one net in static, right? I will discuss more flavor of static net, like one to many, many to one, and many to many. Okay, like these things. So we can have like multiple IPs also, multiple port number also. So those things we will cover in tomorrow lecture. Okay. So don't miss the lecture, guys. Okay.